So carrying on from our last video, we're going to finish up this calculator app to the point where we can do some basic calculations, plus, minus, divide, times. And then we're going to move on to other things. This is going to get fairly complicated too fast to fully complete. And we will come back to this calculator once you've done more advanced videos. And then we'll finish off the more advanced things, such as handling these order priorities and doing more than basic calculations, so that you can fully understand what we're doing here. So the last few videos you've learned a lot doing this calculator. You've learned about string replacement, parsing, switches, we've done some link. So you've gained a lot of knowledge doing this, but now it's getting to the point where this is going to start becoming too complicated to follow at all. So we'll move on to fresh applications starting from the beginning and going over some other things. So let's finish up this calculator so that we can at least do some basic calculations. In this video really we'll go over switches again, which you've seen before, and we'll effectively resolve equations like 4 plus 5 divided by 2 times 3 type of thing. We'll do that final stage. So let's get to it. So we left off here the last time. It was quite a long video, so we effectively just stopped right in the middle of our tracks. We were in the middle of parsing the input string that the user enters. So if we press F5, and you'll see the calculator, and we type, say, 4 plus 5 divided by 3, and hit equals. We then get to this point where we do the parse operation. We put a breakpoint here, and we press equals. You'll see the input is that string. Then we first remove all the spaces, so we get a nice flat equation. We create a new class of operation which we created. We start off being on the left hand side, and then we started looping through this this string. So one at a time, starting at the first position, so starting at the number 4 in this case. And then each time we go through, we're going to start figuring out what each thing is. So right now we've got to check for whether it's a number or a dot, because it could be a partial number. And if it is, we check if we're on the left side of the operation at the moment, which are. So we add the part number to the operation we've currently created, so to the left side of the operation. We add the character, and all this add part number did was effectively add it to this string, but first it checked if there was already a dot in the number. Then that's invalid, because a partial number can't have more than one dot. So now we need to go ahead and do this if we're on the right side, which we obviously haven't done the code yet to swap over to the right side, but obviously this is where we're checking for a number. We know that we can be on the right side. So if it's not left side, we know it's right side. Copy and paste that code above, change it to right side, and change that to right side. And that's as simple as that. If we set this left side to false and then the next thing's a number, it will then try to add it to the right side instead of the left. So that's really it for the number. We check if it's a number and we add it to the left or right side. So that's this if statement done. The next thing that we expect in part of this equation is these operators. So a plus, a times, a minus, or a divide. So again, save a little bit of time, copy and paste your code. Now you could just do another if, but because this if it's true, then the next one can't possibly be true, because if it's a number, then it can't be a plus, minus, times, or divide. So you can, in this case, you can do an else if, and that simply means you could have, if this was an if and that was an if, and it could be this and could be that, then that's okay. But if you're expecting one or the other to be true, then you use if or else if, because then if this if's true, it won't even try to evaluate this, because it's saying else. So else means if that wasn't true, then try this one. So this is a case where we're checking the type of the character, and we're only expecting it to be one or the other. So it's an if and then else if. And we might go into the if and else if a little more detail in a short video, perhaps in the next one. So all we've done is copy and pasted this statement and changed the expected characters to plus, minus, times, divide. So the code stays exactly the same, and we've explained this in the last video. This is checking if the character is equal to any of these. So this will now check if this is an operator. So and then if it is, we want to set the operator type. So again, similarly, if we are on the left side or the right side, we need to do different things. So if we're on the right side already, so if we've got the left-hand number, then we at some point got this operator, and then we got the right-hand number, and then we hit this next operator. So in this situation, if we got into here, because we had an operator and we're on the right side, then we should calculate. We know then we've got a left, a right, and an operator. So we should then go ahead and calculate this section. Use this as now the new left-hand side, set this to the operator, and then carry on to the right side, and sort of repeat that loop. So this will just jump backwards, resolve this, and set this to the left side. So again, we haven't done that bit yet, but we know that's going to happen. So let's make a note of that. So if we're on the right side already, we now need to calculate our current operation and set the result to the left side of the next operation. So if not left side, so in this case that means right side, obviously, because if you're not left, you're right, you're one or the other. We get operator type, and we need to do get operation type, which we'll create in a moment, from the input. So all this is going to do, we created this operation type enum over here for a nice, easy, human readable statement of what the operator is instead of checking for a string. So we're just going to pass in that string of effectively a plus, a minus, a times, or a divide. Oops, we've got a dot there. And then we're going to return an operation type. So let's create that function. So it's going to be a private operation type, and it's called get operation type, and we're expecting a character as an input. This is where we're going to use the switch again. So a switch is like a lot of if or else ifs, as we went through in a previous video. So you say switch, you pass in the thing that you're checking. Open and close curly brackets like an if statement. You use the word case, and then your expected value, and then a colon, and then you do whatever code you expect here. And if it wasn't to return something, you'd type the word break and semicolon. And then your code goes here of what you want to do in the case of that. So we could have, say, case plus minus. The equivalent in if and else ifs is if character equals plus, then your code would go here. Else if character minus, then your other code would go here. So you see exactly the same thing. It's just that switches are typically used so that you don't have to write this if equals, else if equals. It's a bit shorter. So a switch is nothing more than an else if. So in this case, if it's a plus, as we mentioned, we don't need the break because we're returning, so the statement can't continue anyway. We want to return an operator type add. If it's a minus, I'm sure you get the idea now, it's a minus. And then you want to divide and a multiply. And now you'll see here this is still red, and this is saying not all code paths return a value. And that's because a switch statement, it takes in a character, in this case, it checks for these 4. Now the issue here is this function has got to return this value. It's what it's got to do. It's expected to return that value. So whatever happens, it must return that value. or it must throw an exception, one or the other. Because we're only checking these 4, well, what if we passed in the letter B? Then none of these match, and then what happens? The statement ends and nothing returns, so it's invalid. So you have to return something, and because these are the only 4 valid options, we're going to throw, as we mentioned before. If we throw, then in this main parse operation, it's going to bubble up to this try catch, and it's going to land here, and then it's going to output whatever message we put in a throw. So it's a nice quick way of escaping the whole calculation loop and just passing out a reason why we stopped, what the issue was. So in a switch statement, you can do what's called default instead of using a case. And default will match if none of the other cases match. So in this case, if none of those match, then we want to throw a new, say, invalid argument exception. That's what I'm thinking of. Maybe that's not what I'm thinking of. Invalid operation exception, there we go. And then we're going to pass in a message, and we're going to say unknown operator type, and the character we passed in. And there we go, that's a nice simple function. We need to comment this function. And then in these comments that we're doing, these XML comments that are really useful for, as well as being when you're typing your own code, you can see the comment there. You can actually use things like GoScript or other platforms to automatically generate help files on your code, and you might have seen them on Microsoft or MSDN or other sections, and effectively it shows you all the code for third-party developers, and it shows you these comments. But because it's similar to a web page, if you want to link to, like, this is a known type, this is an enum that we wrote with more comments and details. So instead of just typing here, accepts a character and returns a known operation type like that, when this gets exported to, say, a public help file, this would just be the text here. But what we can do is add sort of a link, like on a web page when you click a link to go somewhere. We can add a link to this exact known type, so that if somebody's reading the help file and it returns a known operation type, they can click this and it will take them straight to the documentation of the actual type. So again, it's a little bit over your head right now, but it's useful to know at a glance. And to do that, instead of just typing the word operation type, you do a lesser than sign, you type C, and then you just press space and inserts this cref, and that's like a now expecting a known type. And then you type in, and you can see you're getting tally cents then. Operation type and tab. So instead of just putting the word operation type, we wrap it in this cref. That effectively allows the documentation to be clickable when it's exported. And again, you won't really know what that means right now, but if you're typing comments, again, get into the habit of, if you're typing a comment and you're talking about a known type, something that's actually you can click on and press F12 and go to, and there's some more information about, then get into the habit of doing this. And again, further down the line, that habit will really benefit. Parameter character is the character to parse. And that's it for the get operation type function. So we go back to our calculation. So now this will get the type of operation. So let's quickly test this. Click here to add a breakpoint, press F5 to run. Let's type 4 plus 3 equals. You can press F10 to step over code. So we're going to step over, we've got 4 plus 3. You'll see we've got the left side, we're going to go through the first character. The input 0, it should give us 4, and it's going to check if it's in here, so the first thing should be true. So yeah, the character is effectively matched in there. Left side is also true. Then we're going to try and add. Left side is currently blank, and we're going to add this number 4 to the left side. So press F10, and you can now see the left side is 4, which is good, that's what we expected. You see it didn't even try to evaluate this if statement because it was the previous if statement was true. F5 again, you can see it's now jumped to here to now increment the I to go to the next stage. It's then doing this check to make sure that I is still less than the input length, which it is. So it comes back in, and now I is 1. So now we're going to check if the next character, which is a plus, is any of these, which should be false, which it is. And now it's going to check if it's any of these, which it should be the plus, which is good. So we've got in here. Now, if we're not left side, which is where we get an issue because currently we are a left side. So let me just tweak this so we can show you just the code running. So let's just edit this on the fly. And now let's check this function. So we want get operation type. Press F11 to go into this function instead of stepping over. And then F10 to carry on stepping through. So you can see the character is plus. So we should hit this case and return this add, which we do. So now operator type is add. So you can see briefly how the code's working there, which is as expected. So this is the case when we're on the right hand side of the operation, and we want to, we're presuming, we're working a bit ahead of ourselves here because we haven't done the left side yet, but this is just the way I'm doing it because I know this is what's going to happen. So if we get here, which means we're on the right side, and we've now hit an operation, we know we've had a number. So say we've had this number, then we've had an operator, then we've changed the left to the right side, because that's when we'll do that, once we hit an operator and we're on the left side. Then we get another number, or maybe we don't, maybe we just got another operation, but for now let's presume we've got another number. And then you hit an operation, and then that's when you'd hit this statement. And then you'd now want to get this operation type just to save it. Then you want to calculate this, which should be stored in this operation class, because we've added the operation left side here, the operation right side here, and we will add the operation type in a min in this function. So we do that calculation. So in fact, let's do this the opposite way then. Let's jump back to when we're on the left side here, so that we can do sort of in order, make it a little bit easier. So we've done the left side, we've put a number 4, we've found it, we've added it here. We hit a plus, we come in here. We're currently on the left side, so we'll get into here instead. So we want to do exactly the same thing here. We want to get the operation type first. And then we now want to check, because again, you've got to presume the user could enter anything. So maybe we just typed plus in the string, and we don't even have a left number to work with, or maybe not even a right number to work with. So let's put a little comment here, get the operator type, do the same above, and now we want to check if we actually have a left side number. So to do that, we just want to check if the operation dot left side length is nothing, so it's a 0 length string. Then we know we don't have any information. In fact, there is a situation where this would be valid. So you imagine the equation -4 plus 5. That's a valid equation. So we might actually hit an operator that starts with a minus, and then that's a valid situation right there. So let's maybe not fully handle it, but let's check that the operator type isn't a minus before we error out, because a minus might well be a valid function. So check the minus. So if the operator type isn't equal to minus, so equals means if it is, exclamation equals means if this is anything except that value, so if it isn't equal to that. So if it isn't equal to that, we need to throw an exception, so an invalid operation exception, because obviously that's now not a valid thing to do. So we want to say operator, so plus times divide or more than one minus, because you can't have a minus minus. Well, you could have a minus minus number, but we're just gonna presume they didn't mean to type that. More than one specified without any left side number. So if they put, say, and again, it depends what you want to do here, because you could technically say that even the plus, like +4 minus 5 is technically valid, but you never really see +4 written as, there's no need. Plus is expected. If there's no minus, it is a positive number. So we're going to not allow that. We're going to, throw an exception if that's the case. So that's that bit taken care of. So if we got here now, so we wouldn't hit this line of code if it wasn't a minus number, because we'd throw. So if we get here, we know the operator type's a minus. And in that case, we want to add it to the left side of the number, because then they've typed, say, -4. So the start of the number now wants to be that operator itself, which is the minus. So if we got here, the operator type is a minus, and there is no left number currently, add the minus to the number. So we just simply do operation dot left side plus equals the input. So that's going to add, it's going to append that negative, that minus sign. And that is all we need to do for if the left side is minus, I believe. Yeah, so if we've now got an operator and we do have a left side number, so we do an else. So if we get here, we have a left number. So we are currently in the left number. We have an operator, so we've done a for, then a plus, say. Then we already have a number, so that's okay, we can move on. So effectively, if we get here, we have a left number and now an operator. So we want to move to the right side. To do that, we need to set the operator first, or the operation type, which simply equals the operator type we got above. And now we want to move to the right side, because now we need a right number. So we simply say, left side equals false. So now we're on the right side. And then this loop would continue. So then we'd come into here, then we'd hit, say, the number 5. It'd come into there, it's not the left, it'd be the right, so we'd hit the right side. And then let's say now there's a times. So then we'd come back through the loop. It wouldn't be that, it would be this. We'd come into here. It's now we're on the right side and we've hit another operator. So then we could do this calculation. So before then, let's first start with the basics. We've now got enough information to do a calculation. We can pass in, say, 4 plus 5, and this would run. We'd hit here. Well, in fact, let's run the code so you can see what I mean. Press F5. 4 plus 5, and press enter. So we're going to come into the first one. We're going to hit here. We're going to get a left operator. The left's now going to equal 4. We're going to go around again. It's not that. It's now this, and we're still on the left side, so we're going to go here. We're going to get the operator, which is add. The left side isn't equal to 0 because we do have a number, so we're going to get here. Set the operation type. The left side's now false. It's going to go around again. This is now going to be the number 5, so it's going to go into here. We're not on the left side, it's the right, so it sets the right side up. So now we've got 5. So at this point, we've now got the left side number, which is 4, the right side number, which is 5, and we've also got the operator type add. So here's enough information to now do a calculation. So what's going to happen to our code? Well, we've now run to the end of this string. So we've done 4 plus 5. So you'll see now this for loop does a plus, does a check, but now 3 isn't less than 3, so it's going to come out. And right here we just temporarily put the return empty string. Well, now if we've finished the finished parsing the string, so everything the user typed, and we get out, we're going to presume if we've come out of that, we've simply got an equation left to calculate. The only time we should finish this loop and come out is when we've done with all the other inner calculations, and we've simply got this operation left to work out. So outside of this for loop, when we've done, we simply want to calculate the operation. So if we are done parsing, were no exceptions, calculate the current operation. So we want to do calculate operation, and it's going to accept an operation. And let's make this function. So this time let's use the shortcut control and dot and then enter. And then we want to calculate this operation. We should comment this. Calculates A, and then we're going to reference this operation as we mentioned before with a cref, so that it's helpful in external documentation. Calculates, and it should be an, calculates an operation, and also I want to return the result, and then we want to return the result here to the caller, because the thing that calls it sets up the text for us here in the parse operation, which gets set here. So we need to return the value in order to actually update the result string. So calculates an operation and returns the result. This operation is the operation to calculate. And now this gets down to the crux of the whole purpose of the calculator. The thing that we started at the very beginning was to calculate some equation. We're now finally at that point where we have a left side and a right side and an operation. So we have enough information to now do a calculation. And you'll be surprised how simple this then is. Once we've done the all this is the complicated part here, is parsing the user's string, the typed message, into a formulated equation that a computer can actually work out. So maybe you'll appreciate a little bit more when you use any math programs that you can type an equation and it works things out, how complicated that is. So now all we've got to do is take the left side and the right side of the operation, check what operation type it is, and simply perform that action and then return the result. So we're going to start with a value. So let's do the left is 0. And now we want to do the right. And these are for storing the actual number values. Store the number values of the string representations, because the operation contains, if we press F12, the left and right side are strings. They're not, you can't calculate those. You've got to turn them into numbers, which we've done before, and all you have to do is parse them. So before we get to parsing, let's first check some basics again. Let's actually check that we have a left side value, so it's not completely null. And then in the same if statement, we'll actually try to parse that value as well. So check if we have a valid left side number. So that'll be an if string dot is null or empty we'll use. So this checks if the string is completely null, if it doesn't have a value, or whether it's empty. You can even do a null or white space, which actually checks if it's null, if it's empty, or if it's only got spaces in the value, but we'll use as null or empty, which you could just leave out. You don't need to do this. You could just simply try to parse it, but I always like to be as explicit as possible. So we're going to check the left side of the operation. So if it is null or empty, so if we don't have a number, or we fail, so if not, double.parse. So the same way as we did int.parse, or in this case try parse, because we don't want to crash. A double.try parse simply tries to take in the string, so this left side, and convert it to a double. So if it's a valid double number, so if it's say 4.3, then this will succeed. So we're going to try to convert it to a double. The input is the operation left side. The output is the left variable we've just created here. So we've done this operation here. Well, first we've done this. We've checked if we've actually got a string. So if we haven't, it's going to continue to try this. So, well, no, if we haven't got a string, it's going to succeed in this if, and we can do what we want. If it is a value, but then it actually fails to parse to a double, then we're also going to fail. So this is saying effectively if we have a blank string, or if it isn't a valid number, then what do we do? So in that case, we then need to, again, throw an exception. Because if we don't have a number, we can't work anything out. So we're going to pass a message right back up. And we're going to say left side of the operation was not a number. And then we're going to actually pass that number out so that the user can see what the left side is and what the issue is. Now, just again to test this, let's just return an empty string for now. Let's run this code. Let's hit here. And let's see if we can just do a, say, +5, so there's nothing on the left side. Let's not bother stepping through this for now. Let's just run it and see. Ah, no, you see now, we've already caught the issue somewhere else. Invalid equation, operator, plus times, divide, or more than one minus specified. Now that's, there you go, without a left side number. So this thing's been smart enough to catch that instance. So it's going to be hard to check. Let's try a minus +5. Haha, there we go. So by minus +5, we've got around that check. So you can see the left side number is a minus, which was the start of creating a negative number. Then we put the add and then the 5. So now it's going to go into calculate equation. And we're going to get here, and this should fail because it isn't empty, but we've got one. However, this double.try parse should fail because minus isn't a valid number. So this should fail, which it does, and then it will throw, which will then come back into this string. Left side of the operator was not a number, and then it shows the value, the minus, which is the left side. So that's all working nice. So if we don't have a left side, we also need to check the right side. Again, copy and paste this exact thing. Change left for right. You have to be really careful when you copy and paste code as well, because it's very easy to copy and paste code and then miss out changing a value. So we could accidentally leave that as left, for example. So if you do copy and paste code, be really careful that you fully replace everything inside that copy and pasted code with the new expected value. So we've checked if we've got a left and a right number. If we have, then it's a fairly simple case now of calculating the result. And now, because we're dropping back to mathematical equations which can crash, so if you tried to do say var I equals 0, var j equals 0, var k equals I divided by j, this is then going to try and do 0 divided by 0, which the last time I ever did this in C# crashes the application. I think C# 6 might be smart enough now to return double.infinite or something like that, but let's see, this usually crashes the program. So we're going to have to do 4 plus 5. So here we're about to attempt to divide 0 by 0. and look, it crashed and bubbled up. But nicely, our program won't crash, you see here, because we've already got the exception caught. So it's already going to now output invalid equation attempted to divide by 0, which is something that the system threw an exception of. Now this is okay, except it doesn't really tell the user where this happened. This is just saying invalid equation attempted to divide by 0, at what point, where, what failed. So instead of just crashing, if we do an invalid calculation, we want to do another try catch inside this function, just so that we can pass back a more explicit message about what actually happened. So we'll wrap this part in a try, and you'll see why in a moment. I'm then going to use another switch, and this time the difference is we want to check what the operation type is. And then we're going to do a case. I'm going to do an add. And if it's an add, we simply want to return the left, which is now a double, an actual number, plus the right. So there's a mathematical equation we've done. And then because we're expecting a string, because we're just setting up a label, we do .toString. And that's it. Believe it or not, there's your calculation to now work out 4 plus 5. So to do the rest, it's as simple as copy paste, add minus, divide, multiply, and then you simply change the symbols, and there you go. There's the calculator. In essence, it's all boiled down to these few lines of code that's been about extracting a number that's the left side, a number that's the right side, and a type of operation that we can then convert effectively the add to the actual add. So that's been a very long-winded process to get down to a very simple computer equation. There's a few more things we need to handle. Again, as we mentioned, this is a function that needs to return a string. This switch is okay if the operation type is one of these, which you'd think is the only possible option because the operation type has only got those 4 options. But the operation type could well be something that isn't in there. You could pass in a number and cast it to an operation type, which, there's ways about getting an operation type that isn't one of those. Plus, the switch statement isn't smart enough to know whether you've handled every possible situation. Well, actually, in this case, remove that to be sure. No, you see, so it can't understand if this isn't one of those. So we have to handle the situation where the switch might not be one of these values. So if we don't have an add, minus, divide, or multiply, then we simply throw a new exception. Well, let's keep it standard as we were doing. Invalid operation exception. And we will say known operator type when calculating operation, or in this case final. Well, no, it might not be the final one. Calculating operation, and the value is operation.operation type. So now we've handled that. We've returned all of those. And now we've also got to handle if we do throw from, say if we've done here, if the left was 0, the right was 0 and did a divide, this would crash and come back with attempted to divide by 0. So we just want to wrap that message up in a bit more explained message. So we want to do a throw new invalid operation exception. And we want to do failed to calculate operation. And then we want to give the actual operation. So operation.left side, operation.right side, operation type, then the operation.right side. So this will simply output, in our case, 4 plus 5. So we're going to say failed to calculate operation 4 plus 5. And then we're going to give the reason why, which is the inner exception. Well, it's not the inner exception, it's the message of the exception that got thrown by the system itself. So let's give that a run, and let's see what happens if we do 0 divided by 0. For 1, we should hit here. So let's see if that's where we hit. equals. And we get not a number. So it's actually not failed, which is interesting. So let's debug and see why. So calculate operation. So we do 0 divide by 0. And that's really interesting. So we've got two different situations here. When we've done a 0 divided by 0 there, it's returned not a number. And yet when we did it before, it returned can't divide by 0. Now I'm guessing this is because these are doubles and before we had integers. So let me just test that theory and see if this will throw. And it might be that you only get the exception being thrown when you divide two integers together by 0. Yeah, so if you divide an integer by an integer that's 0, you get the exception. And then you get this nice new message of failed to calculate operation, 0 divide 0. Attempted to divide by 0. So there we go, that's the exception being caught. But obviously, if you're attempting to divide a double by a double that are both zeros, then C# is quite happy to say it's not a number, it's a special double type. So you could also see here double dot, and then these were the new ones I was talking about. Not a number, negative infinity, positive infinity. So in a double, you've actually got these very special things that represent, you know, those types of values. So we're just going to return that. We could go further and actually catch things like NaN and check if it's not a number and then return a nicer message instead of just NaN in case the user doesn't know what that means. But for now, this is good enough. It's actually calculating by the looks of it. So let's now check out. Let's do an actual calculation. Let's do 4 plus 5, and this should now work out as 9. So I'm going to calculate the operation. We're fine with that. There you go. We've actually got a working calculator. At least we can do some very basic stuff. So 4 divided by 3, 1 3 3 3 3 3 3. Let's do pi, which is 22 divided by 7, I think it is. There we go. So you can see we've got this calculator working. You'll also see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 digits in a double. So that's where the limit of the equations worked out. Let's go ahead and change these to decimals, which is the most accurate precision number that we can use. Change everywhere we've got the double to a decimal, which is simply there. And let's see how accurate we now get the number. So 22 divided by 7. And you can see there's the difference between a double and a decimal. Look how accurate the decimal is compared to the double. So let's leave that as decimal because that gives us a much more accurate calculator. So what happens if we do 1 plus 2 plus 3? We get 24. So something's clearly gone wrong there. So we could go through and debug what the issue is. Let's have a quick look. So step through this one at a time. We're going to get 1, which is fine. We're going to get plus, which is fine. And then the operator type is now plus. Which is fine, okay. And now you'll notice we should get to this stage where we haven't finished, because we're now on the right side. We've now got the next thing, which is the times, and now the operator type we're simply going to change to add, which is because we did plus twice, so it's simply plus again. Okay, so nothing's changed there, but obviously this is wrong now because we should have calculated. But let's just see why we got 24. So now we're not on that side, and then you see what's happened here. So because we didn't do this, we haven't finished this part of the equation yet, we should have at this point gone ahead and calculated. So when we're here and we did 1 plus 2 plus 3, we did 1 plus 2, set up the operation, and then we did plus, and then we hit here. This should have then gone back and first worked out 1 plus 2, set that as the left value, which would then be the answer of that, and then start setting up for another equation. Instead, we basically did nothing. We just ignored the fact that we had a full-blown equation. So we did 1 plus 2, so now the right side's 2. We basically ignored the plus because we did nothing with it. And then we come back in and now we've got 3. So what it ended up doing is adding 3 to the number 2. So we ended up with 23. So then it worked out 1 plus 23, which is 24. So if we did 1 plus 2 plus 3 plus 0, that should effectively do 1 plus 230, which is 231. Which it does. So the issue here is we need to finish this last part of the, well, at least the last part for this, this calculator that we're doing now. This is enough to keep you, going, and we'll come back and finish this fully. So we'll go backwards now in time to the point where we were doing what happens on if you've got your second operator, and you need to work out then what you're going to do with that. Which we mentioned, you now need to just go backwards, work out the operation, and then carry on forward. So we've got the operator type. We now need to check if we've got a right side value, because if we don't have a right side value, then we can't work out the previous equation. So if we did, say, 1 plus times, then you'd have 1, which would be the left side. You'd do plus, which would be the operator. The plus would then set you to the right side over here. Then you do times right away, you'd end up gaining to here. So in a situation like that, we could be in here and there simply isn't a right side to calculate. Now you can ignore that check because the calculator here, when we calculate it, we already check if we've got a right side number. So you can quite happily just not do that check here. But again, considering we've done the check here, we might as well do the exact same thing. That we're going to check a very similar thing. So let's copy and paste that. Check if we actually have a right side number. So if we don't have a right side number, then same thing. If it's not a minus, because you could also have a minus on there at the right side, then we want to throw the exception. Otherwise, the right side. Let's think this through. Yeah, so if we don't have a right side yet, if it's not a minus we throw over is, then this counts towards the right side number, just like the left side. So we're repeating this logic. This exact logic is here, just for the right side. So that's good. That's definitely the same logic that we expect. The only difference is this else. So if we're on the right side, and this time we hit an operator, and we have the number, when it was on the left side, what we needed to do was set the operator and jump to the right side. If we're already on the right side, then what we need to do is, as we mentioned, calculate that operation that currently exists, the previous one. So let's store the current operation. So let's call it old operation. It's the current operation. Then we need to, as we mentioned, we need to now work out that operation and set that value to the left side of what's now going to be the current operation. So the old operation really is the thing that, at the moment it's the exact same operation. But we want to keep a value of that because we're going to change this operation. So operation left side equals, and then we're just going to use our calculate operation function that we made, and we're going to pass in the old operation, which we might not need to do. In fact, we don't need to do because we're not changing anything, because this is going to run first and then come back and set that up. So we should just have to do operation.left side as the result of the operation itself. So that's, if we've got an operation right now that's called 1 plus 2, what this is going to then do is change, it's going to work out that operation of 1 plus 2, return the result of 3, and then set that operation's left side to 3. Now the operation type and the right side are still the previous values. We now know the operation type already because we're in the next loop already. So calculate previous equation, left side, set new operator. So that's set up a new operator, and now we basically want to be on the right side because that's the only thing that's left. And we should already be on the right side because we've checked here. So that's actually all there is left to do. So if we get to the right side and we have another operator, so 4 plus 5 times and then something. So we'd get the left side, the operator, the right side, and then when we hit this operator, this is where we come into this part of the function. The right side isn't empty because it's 5, so that bit's skipped, and we hit here. So then we calculate the operation, which is currently 4 plus 5, so the result should be 9 and go back into the left side. So then we end up with 9, and then we're currently plus because it was plus, so we change the operator type to times. So 4 plus 5 times something should then become 9 times with no right side. So we need to clear the right side, because right now it would have been the previous number. Clear the previous right number. And let's run that, and that should now allow us to do like the 1 plus 2 plus 3. So we do 1 plus 2 plus 3, and then we put a breakpoint like here where we expect to hit. When we hit this part, this should be when we've done 1 plus 2 and then this plus, and then we should come into here. So let's see what happens. So let's look at the operation. So yeah, we've got 1 plus 2. So now we're going to work out that and set it to the left side. So 1 plus 2 should become 3 because we're going to set the left side to 3. So it is, but you can see it still says plus 2. So the operation type's now the new operation, which is actually the same, which is 2, and we're clearing off the right side. So now the new operation is 3 plus, which is what we expect. It's now worked out the previous operation and set us up for a new one. And then if we carry on stepping through, it should just now carry on its normal loop. Goes to the next part, it's a number. We're not on the left side, so it sets the right side up as 3. So now it's 3 plus 3. There's nothing else left to calculate, and then it works out 3 plus 3. So there you can go, you've got 6. So now what we have in this calculator is you can do 1 plus 4 divided by 3 divided by 2 times 4.5657, or 5678 rather. Easy to just work that out. Now what we mentioned that we haven't done in this calculator, and what we'll do in a future video once you have enough knowledge that this calculator app makes more sense than it does right now, we'll add the order of priority. So if this was an equation now, 1 plus 4 divided by 2 times 4 point blah blah blah, this right now will work out this, then it will work out the result of that, 5, then it work out that, then it work out that. It's just working left to right, whereas in truth this is an equation in maths. We'll make it simpler. Let's do, so you can see how it works. So we do 5 plus 5 divided by, no, let's do 10 plus 10 divided by 2. So if you did 10 plus 10 is 20, divided by 2 is 10. So that's what our calculator is going to work out. Now if we open up the calculator on the Windows computer, you can't do it in here as the exact same thing, but yeah, ignore me on that one because this doesn't do it as advanced as ours. But basically, if we were to work this out in math, you'd first work out this, the order of priority. So you'd actually do 10 divided by 2 first, which would be 5, and then you'd work out 10 plus 5. So the real answer was 15. But our calculator works out 10 because it's working out left to right. It's not working out these priorities first. So in future, like I say, when we visit this again, we'd have to do something slightly different. Instead of just working out the left side of the equation, when we get to, where are we? When we get to here, and we just instantly go, oh, let's work out this side because we're now here, you'd have to start storing these equations, these operations. So instead of calculating it right now, you'd store it as an inner equation, and then you'd move on and work out this. And then what you'd do, once you've got a group of all your equations together, you could then go through and prioritize and find the operators of the higher priority, calculate them first, and then extract them that way. But that gets really complicated, so that's the reason I didn't want to go too far in depth with this calculator, with it being mainly about you learning switches and if statements and parsing, and it's all about learning the code, not so much understanding the calculator's operation. And now the calculator's only going to get more and more complicated as you go. So I think we've taken this calculator far enough that I hope you've learned a decent amount of code from it. Like I say, don't get too overwhelmed by how much of this logic, if you will, this for loop and this whole logic here. Don't be too concerned about how much of that just doesn't make sense, because this is something that most people can't even do when they're senior developers. You know, you can give this challenge to a senior developer, and I'd say 50% can't even do this anyway. So this is quite a complicated thing to do mentally in your head as well, and keeping track. You can see when I'm working this out, I'm sitting there and figuring it out as I'm going, and you can see that I'm having to think about it myself. And I've been programming since I was 10, and I'm now 29. So I've had 19 years of experience at this, and yes, I can do these things, no problem, but it's not like they just appear in your head and you instantly know. You're always working out as you're going, you're thinking it through as you're going. And if I wrote this calculator up today, and then come back to it in a week, I'd have to read through this and re-understand it, because it wouldn't be in my head straight away. I've worked it out at the time, and then a week later not really thought much about it. Hence why comments are so useful in code, because as much as you think it makes sense, everything right now as you're typing makes sense. Go away, have a meal, have a sleep, come back the next day, not so much sense. So again, I know we always iterate this, but really do comment as much as possible. You know, I like to see green everywhere in code. Just add comments everywhere. Right, so I'd say this is enough, like I say, for this calculator app. There's still a lot to learn though in C#. So we've done switches, ifs, parsing, link, functions, events. We've done quite a lot over the last 7 or 8 videos. We now want to do something totally fresh, so you don't just keep going on this and get a little bit bored with doing the same thing. We want to do something a little bit interesting now. So in the next video, we're going to create the game Tic-Tac-Toe. So if you've never heard of it before, noughts and crosses, basically a grid of 9, so a 3x3 grid. A player goes first, and they put a 0. They pick whether a 0 or an X. I believe there's a rule on whether you're the starting person. I believe you're a 0, otherwise you're an X. And the rule of the game is to get a row of 3, diagonally or horizontally or vertically. And we're going to make that game. We're going to do it in a single video, hopefully less than 1 hour, start to finish. And you should fully understand that game. Like, you should understand every single part of that game. Believe it or not, you've got enough knowledge from the last videos to completely understand to create Tic-Tac-Toe. So it'll be good to see how that all comes together in a real game. So that's what we'll do next.